Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
Your co-host, Rich Geer, here as usual. And Doug, we're going to talk about rocks to people. What's that all about?
Well, that's really what you have to deal with when you're dealing with evolution, is that you're really, if you don't believe in that God created this world, then you have to come up with a scenario where you actually have to start out with rocks, or even a little bit even further, like the old joke about get your own dirt, you know.
Oh yeah, that's a good joke. Yeah. Well, I mean, obviously people, and we've brought this up many times in the past. People say, well, might have been outer space aliens. Well, that just begs the question, puts it further out, because where did they come from? There has to be ultimately what we're dealing with here, Doug, is the uncaused first cause. You're always going to get back to that, because we know that everything in nature, everything we see, what's the law of biogenesis? Life always comes from life. Well, how did it start? That's the ultimate answer, and you can either have an evolutionary answer or a theistic answer. Okay?
And the evolutionists will say from hydrogen everything came from.
Right.
And so they will start out with hydrogen, and then you have all these different things that processes that would have occurred to get nuclear generation of different things to sort of get all the elements. Now, it turns out that there's sort of like an upper limit of what elements you can actually get from nucleogenesis. So it's already at the making of the substance of life. You've got a barrier that you can't. Is an impasse where you can't.
Right, at every scenario, Doug, and you as a chemist, or studying chemistry and all those experiments we've talked about many times on this show, you're trying to improve on Miller-Urey's experiments and things of that nature. For those who are not familiar with that, that's where the famous life in a test tube, which is really not life in a test tube, but that's what everybody refers to. It's been thoroughly really disproven, discredited, kind of cast aside, but they still use it when they want to use a soundbite to convince you that life has been proven to come from a test tube, spontaneous generation. This is really what it is, Doug. We in every level, spontaneous generation has been disproved. And of course, what is spontaneous generation? Life from non-life. I mean, it's been disproved at the macrobiological, microbiological, so they go down to the subatomic level. But even that, it's got all of its problems, as you're bringing out, that there are fixed upper limits. In every scenario we come from, especially from observational science, nothing ever combines into a more complicated form.
That's right.
Nothing ever does that. It always breaks down into simple forms.
Well, that's it follows the second law of thermodynamics, where it's just things go from a simple form, go from a complex form to a simple form.
Right.
And it's a heat thing. It's where heat wants to travel to this more stable form from a less stable form, and that's where we get the problems of how did life come about by chance, because what you really have is non-equilibrium thermodynamics going on in life. In
fact, it's so ridiculous, Doug, that even some of the most ardent evolutionists have done, as I alluded to earlier, basically appealed to outer space things. Mm-hmm. There's a new movie we were talking about it just before here coming out called Life. It reminds me of Alien, and at least the trailers are. I haven't seen the movie yet, and I like science fiction. It's a lot of fun, but the problem is people think this kind of thing can be serious. But the big thing going in outer space is they're always trying to find life. They're trying to find water, first of all. They're trying to get things that would be, which we know on our planet, without water, there's no life. But what else do we know about water as far as life goes?
Well, not only is it necessary for life, it's an enemy for the formation of life.
That's what I was getting at. Dingo, ding, 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 ding. You got to give that man a Cupid doll. He got the $50 answer. Why is that, Doug?
Well, that's because if you were trying to actually make amino acids, which are little building blocks that make up proteins.
As opposed to the kindo acids? Sorry, I couldn't resist.
But the amino acids.
The amino acids. Sorry, folks, I couldn't resist.
They need to remove water in order to combine them to form a polypeptide. Poor Paul over there is losing it.
So in our studio audience here, that was fun. Anyway,
but that's why it's an enemy of life, is because you have to actually to form that peptide bond, you have to remove a water molecule in order to make it combine together. And so then you have to go and tag on the next one and the next one and the next one. So you have a chain built up to make the protein, and then they have to actually have it folded in the right.
Yeah, that's me. You see that, and you see pictures of that, the actual right configuration for the things to combine. But Doug, that's the interesting thing. So we run into this throughout the entire evolutionary scenario, and if you will, the creation. Unless everything works, nothing seems to work, Doug. In other words, we know without water we will die.
Yeah, so they're searching
water
for
will prevent any life from actually happening in the first place. So it's like it has to be complete to start with. So all these searches and all these other plans, and of course, light and water on Mars. How many times are we hearing that?
Right. Yeah.
And some of the moons of Saturn and other places like that. We're trying to find. And you know what? The thing from a creationary standpoint, Doug. I mean, Dr. Russ Humphreys made the scenario. He believes everything was made out of water anyway. I don't really care if there's any water out there, ice, or whatever form it is. That's not a big deal for me. The fact of the matter is, properties inherent in matter do not do what evolutionists needed to do. Water destroys life from coming up. I mean, look at it. You look at stuff that's out here, like what does water do when you have metal? It corrodes it, rusts it. And yet the radicals, you get oxidation. Things go down in a real hurry. And more importantly than that, it prevents anything from really happening in the first place.
And water is a goofy molecule.
It is a goofy molecule.
Because it forms a dipole, and you have sort of like a charge on one end and the opposite charge on the other end, and it's sort of like a little mini magnet in itself. And so that's why it actually forms the liquid, is because it has these hydrogen bonds that bonds to the molecule next to it.
I find it very interesting. Water is one of the fascinating things that you look at our planet, so full of water, and you look at it and you say, man, two elements, Doug, oxygen and hydrogen, which by themselves are very unstable. They're flammable, they're combustible, they're not. Yet when they come together, the way they do with two hydrogen and one oxygen, you get basically one of the most stable compounds you're ever going to find out. I mean, it's an amazing thing that water. I mean, yes, you can get it if you have certain enough heat or even you can make it blight up, but it's very, very difficult to do in its natural state.
To separate water into hydrogen and oxygen is a little bit of it takes a little bit of electrical energy. That you have a dipole, and you put a battery in it, and the one electrode is positive, the other one's negative, and
you really have to do a lot. In other words, and it has to be humanly or intellectually decided. It doesn't do it once it's combined in nature. It's pretty much stays where it is, right?
Yeah. So the oxygen goes over this side, the hydrogen goes over on the other side, and you have to capture it so that they don't go boom and combine it back and get together again.
Well, Doug, now what are some of the stories? I mean, we've heard over the years, and I guess one of the things that really gets me, this is from another standpoint, not from the creationary aspect, Doug, but it's from the idea that people they're convinced at one time Mars was covered with water.
Right.
There's no evidence really for that kind of water on Mars at all. Yet when we tell people that the world, this planet was once covered in water, Noah's flood,
right,
and they say, "Oh, that's a myth." I go, "We have a planet that's 3/4 covered in water right now, and you think couldn't have ever been covered with water? Yet you have a planet that's virtually arid,
right?
And you think it was covered? It was in water all. I mean,
where did the water come from?
Where did the water come from? Where did it go? I mean, come on." Anyway, so but I mean, Doug, that Mars. You've listed a couple of moons. Yeah, what Europa?
Yeah, Europa's a moon of Jupiter, and that one actually
Jupiter, that's right, yeah.
they believe that there is water on that. Well,
Might be,
but also it's in such a inhospitable place that life really isn't possible. And then they think maybe Titan and Enceladus, the moons of Saturn, were have conditions where there could be water. Actually, there's on Titan there's lakes of methane.
yeah, oh yeah. But Doug, we always get back to the first point. Even if you found water out there, it's not going to cause life to happen.
Right.
You have to have life already around for the water to work on. That's why the whole Miller-Urey thing, which we talked about earlier, was postulated in the first place, because they needed to get oxygen out, which is a big part of what water is about. Water, oxygen, you had to get that out of the atmosphere before they thought anything. Reducing atmosphere, they called it. Mm-hmm. It was a hydrogen. What was it? What was the
methane,
ammonia,
and hydrogen. Gas.
So yeah, and so they had to do that. And of course, we found in the lowest rocks, even based on their scenarios, it's been impregnated with oxygen. So that didn't really work very well. So that's kind of been thrown out. But
I think
anyway.
one of the things that makes this whole scenario fascinating to people is the old Frankenstein movie, monster movie.
Oh, I used to love those growing up, man. Yeah. Boris Karloff. You know,
and you have these electrodes connected to one end and the other end, and you turn on the Jacob's ladder. It goes bzz, bzz.
Yeah, oh yeah.
And
love those, the spinning wheels.
Yeah, I was fascinated with that as a kid. You remember
I remember
that?
You had a Van de Graaff generator, I remember.
Yeah.
And did you have a Jacob's ladder?
I had a Jacob's ladder.
Did you? Yeah.
A 10,000 volt sine transformer.
Yep.
And that thing went bzz,
yeah.
Bzz.
Yeah, I love that thing. Just looking at that. Yeah, anybody has seen the original Frankenstein movies, you might have seen Young Frankenstein, which used the same sets. But it's the whole concept. Really, in the late 1700s, Doug, there's a lot of that. They would put an electrode like on a dead frog leg, and it would move it.
Yeah.
So they thought maybe they could bring life together. Right. But in the book itself, which is really not that great of a book, I've read it, and it was it was kind of an interesting scenario. She doesn't really explain how he was actually created, but in all of our modern movie incarnations, always electricity. And interestingly enough, that was a big thing back in the late 1700s. That they thought maybe with electricity you could stimulate dead things into living. Nah, not going to happen.
Now, you remember back in our day, we used to have chemistry sets, and I had the chemistry set of chemistry sets.
Yeah.
Where you would have all these different chemicals, and some of them were pretty dangerous.
Yeah, they weren't quite as.
You don't see that anymore.
No, you don't. No.
And if you really wanted to be a chemist, and to actually practice and learn it in high school, there's really nothing now that you can do to. I think that's sort of like a dying science, because people aren't interested in it.
Well, not necessarily. Well, you can't do the things you used to do, Doug.
Right.
To really find things out, you have to try to work with sometimes some dangerous things. They want to protect their children so much today. They don't give them a chance to really learn anything.
To take metallic sodium and put it in a bowl of water instead of having it go poppy pop 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 and explode.
Must have been fun, so, Doug, what are some of the problems with it? Because we've had origin of life experiments. I mean, you talk about the Frankenstein monster. What are some of the issues that we went with? We talked about the idea that
obviously there's certain spots where the evolution it's an impasse to evolution.
Okay.
And the one impasse is that the chemical reagents that you need to create amino acids conflict with the chemical reagents needed to create nucleotides. And so if you have them all together in one pot, you're going to get a mismatch of non-biological goo.
Yeah.
Rather than what you're really.
Speaking of the one who's actually created such a mess.
Yeah.
Doug, what about the left-hand? Oh, this one of our favorite ones we've talked about over the years. The left-handed.
Yeah, this one was the one that really fascinated me, and it was one that really convinced me as a to be a creationist, like, it can't get beyond this one, is that if you created an amino acid and there's 19 of the amino acids that have this characteristic of right-handed and left-handed, and then there's one glycine that is symmetric, so you don't get this problem. But they're configured in such a way in 3 dimensions that one is like a right hand and one is like a left hand. They're mirror images of each other. And so, but the only conformation that life uses is the left-handed kind. And so what this creates as an issue is that if you're combining them together to form proteins, and you have a protein that's on an average of 400 and some amino acids long, well, the odds of getting them all left-handed in a scenario where you get the...
Right, when you create them, it goes kind of equal, doesn't it, Doug? You just make equal right and left. I always thought that'd be an interesting sci-fi thing. Maybe the other could segue with that with the idea of antimatter, then people are based on right-handed amino acids, not left-handed.
Well, they were thinking that the polarization of these left-handed amino acids just would only would be on comets. Comets would create this scenario where it would actually kill off one side of the amino acids. And so then you'd have the purification in one left-handed...
It is amazing, Doug, the lengths that secularists and evolutionists and atheists will go to get God out of the picture. It is just... We've talked about this many times. How much faith does it take to be an atheist? It takes an awful lot. Doug, what about the RNA as opposed to DNA for the origin of life?
Well, they figured out that they couldn't get...
Can't get there from here with DNA.
It can't get there from, starting with DNA. You have to, and you can't start out with proteins because proteins need DNA to code for them.
I know.
But the DNA codes for the proteins.
So
So
which comes first, chicken or the egg?
intermediary is RNA, and so they were figuring, well, maybe it started out with RNA. Well, you need about 3 different kinds. You need messenger RNA, which carries the coding for a new protein, and then you have the ribosome RNA, which surrounds this thing as this is a little factory that adds them together, and there's transfer RNA that hangs onto the amino acid, and as it builds this on assembly line, it creates the growing protein.
Man, you see this. When you ever see, Doug, a visual representation of this, the coolest thing ever. And you go, oh my gosh, this is it's amazing.
And it's such an efficient factory to create this in the body. And one of the things is that there's a mechanism where you get, it sort of measures how much of the protein that you're making. And then it figures out that you've got enough of it, so it shuts it off.
I know.
And the way it works is that there will be it'll attach to the growing proteins, and it'll attach to it and turn it off with by conforming it in a little bit different conformation, so it doesn't continue to work.
Wow. Now, Doug, so we said about the left-handed amino acids, but now we got sort of an opposite thing when you deal with the sugars in life. Those are all right-handed.
Right-handed, yeah.
Now, what does that mean, Doug? The sugars are used for what? For a lot of things.
Well, the sugars are part of the DNA molecule. That's a ribose. And those are right-handed. Deoxyribose
nucleic acid, right.
And so the sugars attach to a phosphate molecule, and then it connects to the next nucleotide in the sequence.
Leg bone's connected to the thigh bone. No, I'm just saying. Yeah, and it's the way that everything's built up, Doug. What you got the right in the DNA is right-handed sugars. Is that the G? I'm trying to think of the 4 letters. The
CG,
yeah, and those are the sugars, right?
No, those are the nucleotides.
Those are nucleotides, sorry, yeah. Anyway, but the point is, the sugars that are used to put those together, is that?
Yeah, they connect. They help with the interconnectivity.
Yeah, the amino acid that builds the proteins are all based on left-handed. They're all left-handed configurations. Anyway, Doug, what we get right down is what I said earlier. Life always comes from life.
Right. And,
nothing ever happens unless everything works. In other words, unless everything works. And Doug, it's not only does everything have to work, it is designed to put, it's always in one way. Life always has left-handed amino acids, right-handed sugars. It never works any other way. Yet when we try to make experiments, Doug, artificial experiments, you get equal amounts of both sides, right? Is that right?
Yeah.
Same thing with the sugars? Is that the same way with the sugars?
right, and that's the way it's. But if you create it in the laboratory, you get the equal amounts. But and a similar thing with fats, the lipids. They have the cis and the trans conformations. The cis are sort of all on one side, where the trans are kind of like this, where they're crosswise that way. And it's the cis that the life uses, and it's the higher energy ones where trans is. You get more of this if you create them in the test tube.
So Doug, okay, so we can't even get out of the box.
Let's suppose we could. Okay?
Yeah, I know, that's the other thing. So we're going to get all the problems you just told you, we're going to just ignore them right now.
Yeah.
And now we're going to go on to the cell.
Yeah.
Okay?
Now you've got everything
We're giving
need.
you that, okay? Which is impossible. I already told you it's impossible, but we're going to let you have it anyway. All right, so what's the problem with the cell, Doug?
Well, here's what you
Besides
need to create. Here's the components of the cell that are going to be needed. You first need to have something to contain it in.
Yeah,
That's the cell wall.
Okay.
And then there's a nucleus, which has its own little wall inside of it. And the mitochondria's got its own containment of different things. Now, actually, mitochondria has its own little tiny bit of DNA in it.
Yeah.
So you have mitochondria DNA as well as the DNA in the nucleus. Now, if you have we're going to talk about this a little bit later, but if you have a prokaryote cell, you don't even have a nucleus.
Yeah, well, that prokaryote, that's a virus, right?
Oh no, it's a quote unquote primitive cell.
Okay.
But it's a kind of bug. All right.
Kind of a bug.
And then you got the Golgi bodies, endoplasmic reticulum, cilia, lysosome, centrioles, cytoplasm. And then we talked about the ribosomes, and then you have the nuclear membrane. And so all these different pieces are what you're going to
Just
have
to make one cell.
To make one cell, you have to actually not only they have to find each other in the sea of primordial soup that you're going to create.
Yeah.
We're making the assumption that the primordial soup exists. In spite of Campbell's and I've been thinking, if you go down to the Creation Museum, they'll have that on the menu. The
primordial soup.
The chocolate chimp cookies.
Yeah.
And the dinosaur burgers.
Dino burgers. Yeah. Well, Doug, because each one of these things in the cell have their own purpose and reason for being in the cell, and they all do different kinds of things, and to get them all together, I mean, how many things did you list? 10, 12 things?
Yeah.
And there's more things than that as far as that goes, but these are I mean, you go any biology class. I remember I kind of was lousy in biology when there was so much stuff in there. I went, oh my gosh, I couldn't imagine that. So you're trying to get there. So that's just in one. So you can't get out of the box rocks into something alive. Okay, the cell itself is so complicated that would give Darwin nightmares before you ever got to the eye. If you knew what the cell was like today, back in those days, it was sort of like a squishy jelly. That's about. They didn't realize all the stuff that was in it. All right, Doug. So we're going to give you the cell, right?
Yeah. Let's say now we've got some cells. Okay, we've got a whole bunch of them.
You got to sell that.
But now you've got to figure out how to differentiate them and make them into multicellular organisms.
Oh yeah,
so
why do we
that-
have a brain and why do we have skin and
Right.
and heart and all that
how
stuff?
do you get all these different cells to cooperate with each other
Right.
from the same code, genetic code, but they would specialize as they would grow into a new organism? How do you get that to work? And then to get the coordination of functionality within all these different cells. How do they transmit things to each other? How do they work within their own different things? And how do they interdepend upon each other? This is the ultimate of biological symbiosis, where you have to...
Everything cooperates with everything else to make a living organism, a multicellular, whether it's a cat to a human, even a simple thing, a mouse, or any multicellular organism that's in light there. Doug, the thing about, at the one-celled animals or even smaller ones, but it's when you get into upper ones and the origin of sex, for instance.
Right.
How in the heck? And from an evolutionary standpoint, it makes no sense. You're much more efficient to be be able to divide in two and not have to worry about it. Anybody who's been married knows sometimes how difficult it is to do that. It'd be easier just to say, I can just divide myself and reproduce myself. But somebody had a better idea, because there's a great lot of joys in that too.
Well, but the other thing is that the life cycle of some of these insects, they go through about 3 or 4 different stages, from a pupa to a larva to from an egg to larva to pupa to the adult.
One of the most amazing is the monarch butterfly, for instance. And I've told people, I said, that's to me a nice scenario for the resurrection, Doug, because it goes into there as a caterpillar, dissolves into a green jelly, and reforms into this beautiful monarch butterfly.
Right.
It's just amazing thing. So.
Well, we're getting close to the end here.
Yeah,
but,
we have so much more too.
But here's the gaposis that evolutionists have to resolve, and these are insurmountable gaps. You have gaps between prokaryotes and eukaryotes, the 2 different kinds of...
Right. No nucleus to nucleus. Yep.
And you have from worms and spineless jellyfish and things like that to fish. From fish to amphibians, from amphibians to reptiles, reptiles to birds, reptiles to mammals, and then from mammals to man. And these are all gaps that evolutionists tries to bridge, but it's based upon some very flimsy little materials, the gossamer bridges.
Pretty much nothing. They're all gaps in all of them. They got this nice tree, and they got things at the end of them and nothing in the middle there. So, well, Doug, I guess we got to wrap it up. We have so much more we could go into it. It's fascinating subject, Doug.
We'll see you next time on Revolution Against Evolution.